Welcome to the world of open finance with BankBuddy, where secure connectivity meets customer-centric innovation. Our platform enables secure, consent-driven data sharing between banks, fintechs, and third-party providers through a robust open finance framework. By leveraging standardized APIs, institutions can accelerate innovation, enhance customer experiences, and launch new financial services faster than ever. Our open finance platform ensures end-to-end regulatory compliance while supporting AI-driven personalization and seamless ecosystem collaboration. Let's explore how BankBuddy is helping partners lead the future of open finance. This architecture illustrates BankBuddy's open finance integration architecture, designed for secure, scalable, and intelligent API communication. On the left, we have licensed financial institutions and third-party providers connecting via Ozone API, as mandated by the Central Bank of the UAE or any standard open finance interface. Incoming requests are first routed through the Ingress Controller and API Gateway, which includes a rate limiter and consent store to ensure compliance and manage customer authorization. The core orchestration happens inside the BankBuddy runtime engine, where messages are processed and routed to relevant internal or external systems. Responses are transformed and returned securely. We've also integrated AI Chemist, our AI-powered engine, which enhances requests with intelligent enrichment using large language models. This includes prompt engineering, guardrails, LLM marshalling, and embedding-based search from the BankBuddy Open Finance platform. Process data is pushed to queues and logged via NATS and the event logger, then stored in PostgreSQL and analyzed through our analytics engine, giving real-time insights to admins and business users. Finally, outgoing responses are transformed and sent back to the external systems, completing the secure and intelligent data exchange flow. This modular integration setup spanning orchestration, transformation, and enrichment is designed for adaptability, enabling consistent performance across a wide range of API-driven business services. Let's look at the key benefits of BankBuddy's open finance framework. First, regulatory alignment and security. Our platform ensures full compliance with global open finance and data privacy regulations. Data sharing is secure, consent-driven, and based on trusted API security standards. Next, we enable faster API transformation with pre-built transformation functions, helping institutions reduce development time and accelerate their go-to-market. Our modular API suite provides interoperable, consent-based APIs for a wide range of use cases like account-to-account payments, onboarding, and lending with seamless third-party integration. We also drive innovation and financial inclusion by leveraging permissioned data and AI to create tailored financial products for underserved and emerging segments. Lastly, with ecosystem flexibility, the platform supports cloud, on-premise, and hybrid deployments, and comes with built-in consent tools, dashboards, and policy controls to simplify compliance and governance. For AI-driven user experiences, BankBuddy uses AI and LLM-powered workflows to deliver hyper-personalized journeys across onboarding, lending, payments, insurance, and wealth. Now, let's explore the key features that make BankBuddy's open finance platform powerful and enterprise-ready. First, our modular API suite offers pre-built, consent-driven APIs for accounts, payments, lending, and insurance designed for quick integration across cloud, hybrid, and on-prem environments. Next is configuration and versioning. With a centralized setup, institutions can easily localize and deploy APIs while maintaining version control for smooth upgrades and ongoing compliance. Our developer portal serves as a single access point for API documentation, sandboxes, and testing tools, enabling self-service onboarding and accelerating partner integrations. Security is core to our design. The platform is secure and compliant with built-in API encryption, FOPI 2.0 support, AML checks, and consent management, ensuring full regulatory alignment. Finally, the analytics platform delivers real-time insights across onboarding, payments, and lending journeys. It includes dashboards for compliance, risk management, and operational reporting. In the next stage of the Open Finance integration journey, users can access the API management module. This is where all API configurations are created, tested, and maintained, ensuring seamless communication between internal systems, third-party providers, and regulated interfaces. From the API management screen, users can view existing APIs, edit their details, or create new APIs from scratch. When creating a new API, users begin by selecting the HTTP method supported by the endpoint, such as GET for retrieving data, POST for creating new resources, PATCH or PUT for updates, DELETE for removing records. Next, users define the API endpoint in a standardized format. This can include dynamic path variables, for example. A placeholder like slot_insurance policy ID allows the system to inject runtime values. Users then select the data format to be used for request and response. JSON, the most common format in Open Finance APIs, XML for legacy or traditional finance systems, URL encoded for specific web integrations. Further down, users can configure request level settings, such as enabling or disabling SSL verification, choosing to bypass the API during testing or debugging. In the Query Parameters section, users define dynamic key-value pairs that form part of the API request, ideal for filtering or pagination logic. The Authorization tab supports multiple security schemes: No Auth, API Key, Basic Auth, Bearer Token. This ensures compliance with security protocols like OAuth 2 and client credential-based authentication, commonly used in Open Finance ecosystems. Additional configuration tabs include Certificate, for mutual TLS or client cert validation, Headers, for passing custom metadata or tokens. Body, for defining JSON/XML request payloads in POST/PUT, Configuration, for setting custom runtime parameters, Cookies, for session-based flows if needed. Users can also define expected responses or set a fixed mock response, which is useful during testing when the live API is not yet available or needs to be simulated. This complete API configuration capability allows teams to rapidly connect to third-party fintechs, expose internal APIs securely, comply with regional Open Finance standards, debug and test each endpoint in isolation. All of this is done in a single, visual interface, making API management both powerful and easy to use without requiring deep developer expertise. This approach also ensures that once an integration pattern is created, it can be reused across various workflows, promoting standardization and reducing rework across teams. APIs are consumed in a seamless customer journey. This ensures that every API operation, such as fetching account details, initiating payments, or validating consents, is fully mapped to a defined user flow for seamless execution and traceability. We begin our Open Finance integration journey at the Start node. This is the first touchpoint where the customer experience begins, whether it's a retail customer checking account balances via a third-party app or a corporate client initiating a payment. At this stage, we define the entry trigger, such as a user request or an API call initiated by a third-party provider under regulatory frameworks such as CBUAE Open Finance using Ozone APIs. From the Start node, we move into Function node. These are designed to handle specific tasks like token generation, account linking, or consent verification. Using prebuilt, configurable functions, BankBuddy helps banks implement complex Open Finance logic without writing custom code from scratch. You can also create your own reusable functions to meet regulatory or business requirements. Examples: fetch customer consent status, retrieve list of linked bank accounts, invoke third-party aggregator APIs. Next is our data transformation, which plays a critical role in ensuring seamless and scalable integrations. It helps accelerate implementation and reduce time to market by simplifying how data flows are managed across systems. Our platform is built on a schema-driven and reusable architecture, allowing configurations to be created once and applied across multiple use cases such as onboarding, payments, and consent flows. It ensures full interoperability between input and output formats, using dynamic, rule-based logic to adapt data in real time. The transformation engine supports multiple formats, including JSON to JSON, ideal for modern open API integrations, XML to JSON, enabling modernization of legacy systems. JSON to XML, for compatibility with older interfaces. By minimizing manual mapping, we significantly streamline partner onboarding and enable faster external data exchange, ensuring reliable connectivity with both third-party platforms and core banking systems. Now, let's look at the transformation node itself. This is where we shape and prepare the data before it's sent to external systems. For instance, we might define a transformation such as transform_request, which maps input, internal data format either from BankBuddy or the core banking platform, output, external API format, fully aligned with open finance specifications. To make this even more efficient, our platform uses GenAI-powered transformation logic to automatically generate input-output mappings, saving development time and reducing manual effort. Once your integration is live, BankBuddy also provides tools to compare actual API responses against expected results. This helps ensure your transformations are accurate, validations are functioning correctly, APIs are returning the expected payloads. The ability to test and validate each integration step also ensures reliability across a wide range of enterprise workflows, not just within open finance. These checks help maintain consistency, accuracy, and compliance throughout your open finance workflows. The API node acts as the initiating call for outbound communication with external systems. Whether you're interacting with a TPP, third-party provider, government KYC registry, credit bureau, core finance APIs, this node ensures that requests are sent securely, headers are injected properly, like OAuth tokens, and responses are handled efficiently. You define API endpoint, method, get/post/headers, params. Before proceeding further, it's critical to validate incoming and outgoing data to ensure that what's being processed and transmitted is accurate, compliant, and reliable. Our platform offers real-time API validation, ensuring every request and response meets the expected schema and format, low-code control, allowing business users to define validation rules through a simple UI, reducing back-end dependency, dynamic error handling with configurable rules for retries, fallbacks, and alerts. No code changes required, reliable API communication, with continuous monitoring of external APIs to ensure seamless, real-time data exchange, compliance, and continuity. Supporting secure, traceable integrations that meet policy and regulatory standards. The validation node allows teams to define expected data types such as string, date, or number, value conditions, like amount 0, custom validation rules, tailored to business logic and regulatory requirements. By validating early in the flow, you can minimize manual mapping, speed up partner onboarding, improve data integrity, prevent downstream errors, and ensure smooth and policy-compliant external data exchange. Validation is a foundational step for building resilient, secure, and real-time open finance integrations. Sometimes, the response returned from an API isn't in an expected format for downstream systems. That's where the second transformation node comes in. Here, we modify and restructure the response to align with internal workflows. Example: external API gives account details in nested format. You flatten the data and enrich it with customer metadata before showing it to the end user. This ensures that the final output is consistent, actionable, and tailored to your channel's needs: mobile, web, or branch. Our platform supports custom logic with Python. Write and test Python scripts for tasks like validations, calculations, and data enrichment, all within the flow. LLM-powered extensions. Leverage large language models to automate intelligent behaviors such as parsing and classifying user intents, extracting entities from documents, generating dynamic responses in real time. To enhance flexibility, the Code Sandbox node allows you to run Python scripts inline, ideal for implementing custom logic such as conditional checks, status validation, and dynamic response handling. Next in the integration journey, we explore the pre-built transformation functions. These functions play a critical role in data mapping and format conversion, a key requirement in open finance, where data must flow seamlessly between internal systems and third-party APIs that follow different standards. Inside the editor, users can view a library of pre-built transformation functions. These are ready to use, fully configurable, and editable to match your specific use cases. Each transformation function typically defines how to restructure payloads from core finance into open API formats, convert third-party responses into internally readable schemas, flatten or nest data in rich fields, or remove sensitive information. When we create wrappers, GenAI is invoked to assist in automatically generating the underlying logic or transformation, accelerating development and ensuring consistency. Using natural language, users can simply add comments or prompts inside the transformation editor. For example, map customer_name to name and convert account_balance to float. The platform then auto-generates the transformation code based on the prompt. This greatly accelerates the process, especially for non-developers or teams working under tight deadlines. These AI-generated snippets are editable, so developers can review, enhance, or directly apply them into the function flow. Once finalized, these transformation functions can be reused across multiple nodes or integrations, ensuring consistency and reducing redundant effort. Whether you're converting JSON to JSON, XML to JSON, or normalizing formats for compliance, these pre-built, GenAI-enhanced transformation functions ensure accuracy, speed, and adaptability in your open finance workflows. Their flexible design allows the same functions to be applied across different business contexts, helping streamline data flows across multiple digital channels and use cases. Let's begin with API Analytics, which provides visibility into real-time API health and usage. This dashboard is crucial for monitoring external integrations. The upper section shows individual API transactions with attributes like API name, status code, channel, and timestamp. Each transaction is split into request and response stages. Notice the 503 status codes. These indicate service unavailability. This lets us immediately flag upstream issues or connectivity breakdowns. Below, we see exceptions associated with each failed transaction. In this case, multiple timeouts are detected with the API_XT_GET_token endpoint. This real-time API visibility helps teams identify failures early and trigger alerts, ensuring better SLAs with integrated partners. The next view further drills down into request and response flows for each API. Here, we can track the session ID, request ID, and associated payload metadata. It provides visibility into which user or session made the call, helping with root cause analysis. Response logs mirror the request structure, adding exception messages for failed calls, in this case, connection timeouts from the external token endpoint. This end-to-end traceability is essential in open finance where third-party APIs often span multiple platforms. It enables teams to troubleshoot precisely which leg of the journey failed. To understand load and usage trends, the total API calls dashboard summarizes the number of calls made to each endpoint. Here, we see that API_XT_GET_token is the most frequently invoked, followed by protected authentication and handoff APIs. This insight helps teams plan scaling, rate limits, and caching strategies, especially when certain APIs are heavily consumed during specific user journeys. The Health Check panel provides a snapshot of the live and last known health status of internal services. Each service, like bot builder, campaigns, charges, and more, is periodically pinged. A green status means the service is up and responding with a 200 code. This proactive monitoring ensures that the core platform and microservices are functioning correctly before troubleshooting external issues. This becomes particularly useful when differentiating whether an issue is from an internal service or a third-party open finance API. Finally, we have the Audit Trail dashboard, which logs any changes made to configuration values. You can see what key was updated, its previous and current value, the environment it was applied in, and who made the change. In open finance contexts, any update to API configuration, credentials, or routing logic must be traceable to maintain compliance and integrity across institutions. Thank you for watching this training session. We hope it gave you a clear view of how BankBuddy.ai supports open banking integrations with CB UAE's Ozone API. Stay tuned for more sessions and reach out if you need any support.